Hello, welcome to Group 104's presentation titled How Do U.S. Gas Prices Affect Alternative Methods of Travel? My name is Matthew Kim, and the other members of my group are Caroline Schmidt, Emma Yang, Mike Genovese, and Osman Yardimsi. So we were able to kind of combine our thoughts into four main research questions. Firstly, how does the average U.S. gas price over time affect ridership numbers of alternative transportation methods? Secondly, which areas show the most increase in transit ridership in response to increased gas prices? Third, do all grades of gasoline fluctuate in price at roughly the same rate? And if not, does one affect alternative transportation ridership more than others? Finally, are there any particular significant events that can explain any sudden spikes in alternative transportation ridership numbers? So to answer these research questions, we came up with a few pretty robust data sources, the first one being the National Transit Database Complete Monthly Ridership. So that is basically a table of time series data for public transportation in the United States, specifically passenger rail. We were hoping to combine that with the U.S. gasoline and diesel retail prices data source and hopefully find a correlation between the two. And we hope to ultimately link that to our final data source, U.S. air quality, so we can have a measurable impact on maybe health outcomes. Some other tables we were thinking about using are the weekly petroleum status report to see if there's a link between that and the gasoline prices, and the bike sharing data set as another form of alternative transportation. So doing some exploration of that first National Transit Database source, we have our exploratory line plot shown on the slide that graphs unlinked passenger trips by time. So we decided that an unlinked passenger trip is a measure of passengers who board public transit vehicles that are not part of a larger trip. So we wanted to find simply the alternative to driving an automobile from point A to point B. Now you'll notice that there is a large outlier in 2020, go figure. So it'll be interesting to see how the variation was before COVID and after COVID as well, and the post-COVID recovery. We did a similar line plot for our second data source, U.S. retail prices for gasoline and diesel, and you can see the result on the slide. So this is just a measure of all grades and all formulations of retail gasoline over time, which is just an aggregate of all types. So that would be regular, premium, diesel, etc. And you can see it's pretty linked to economic activity. You can see a large dip in the 2008 recession. You can see a dip in 2014 to 2016 with the oil price collapse, and a smaller dip for COVID in 2020. Finally, we did some exploration of the U.S. air quality data source. The plot you can see on the slide is a measure of the air quality index, also called AQI, for multiple locations. This AQI value will range from 0 to 500, 0 being the best and 500 being the worst. There's a lot of seasonal disparity between these values, and there's also a little bit of disparity between urban and rural locations. One thing we also want to note is that in 2020, there was a substantial drop in the air quality index, which is a good thing, but we don't expect public transportation to play the biggest factor in that drop.
Just going to talk about how we are going to approach our project. Planned approach, we are going to do the data cleaning, aggregate our data to different time periods, perform necessary transformations, and we are going to build time series models, hyperparameter optimization, ACF and PSF plots, grid searching, and auto RMA, utilizing multiple different model types to test data. And evaluation will be model accuracy by mean absolute error, mean absolute percentage error, and RMC, goodness of fit. And models, because we are analyzing the data revolved around the change over time, we will be utilizing the following time series models. We're going to do the multi-variable models, vector, autoregressive. We're going to do the generalized autoregressive conditional, heteroscedasticity models, gorge models, and we will do the decomposition models. Initial hypothesis, a positive relationship between gas prices and transit ridership will exist. However, we will assume this relationship is any one of many factors that drives transit ridership. A positive relationship between transit ridership and air quality will exist, and the most significant independent variable will be a regular grade gas price. We will see different patterns in different cities due to the different regional availability and existing use of public